This is a tutorial on two of the continuous probability distributions, the normal distribution and the t-distribution. Of course, there are many others, but once you get the hang of it, you can plot some of the others for R. R has a convention that it uses for all of these distributions, both the continuous and the discrete. First of all, it gives it a base name. For the normal distribution, norm, obvious, t-distribution is t, chi-squared distribution is CHISQ, and Poisson distribution is POIS, only one S, it's easy to make that mistake, and binomial distribution is BINOM. So it gives it a base name. Then in front of these base names, it puts a prefix, a single letter prefix, and that prefix could be D, P, Q, or R. I'm going to use this normal distribution, the standard normal distribution actually, to demonstrate those prefixes. So the first prefix was a D. And if you recall, what this plot is a plot of the probability density, and the D stands for density. So when you call D norm, you're getting a value right on this curve. Okay, one of these values right here, depending on how you specify it. Okay, what is the probability associated with this density? It's the area under the line. So if you started here and you wanted the probability that the number was, in this case, greater than 2, it would be this area under here. To get that area, it's P norm. So it's kind of obvious, or once you get the idea of it. So the P gives you this area here. Again, this dot is D norm. I'm sorry. Dyslexia attack. Okay, D norm. Now, the other one is Q norm. And what is Q norm? If you knew an area, say, let me get a different color here. Okay, say you had this area under the curve. Well, pretty sloppy area, but you had this area under the curve, and you knew how big this area was, and you wanted to know the value of Z at the edge of it. This Z value here would be the Q norm. Forget about the R norm. That has to do with some random variables. So this is going to be common to all of the plots, all of the distributions. I'll now use R to create some graphs of normal distributions. So to create this graph, I need to set up some X values. I'll just use that function pretty, which will give me just to get some X values. And let's go from -4 to 4, and we'll have 100 intervals in there, and so we'll let the computer figure that out. Now the Y value, I use D because I want the values along the curve of the normal distribution, and where do I want them? As a function of X. So that's it, I'm done. Now I can just plot it. I'm not going to put any labels on it. You can do that. Let's just give it a line though. Type equals line. That's good enough. Okay. There you go. Now the default for norm is a standard deviation of 0, standard deviation of 1, mean of 0. Its norm is the standard normal distribution, but you are not limited to that. Let me go back here and I will plot a different graph. Let's just, I'll use the example in the tutorial. So now I'm going to get some different Y values, or X values. I'm going to go from -2 to 12, 100 intervals. Whoops. Pretty has 2 T's instead of 2 E's. Okay, now for the Y value, if I just give it D norm and don't specify anything, then it will assume that the mean is 0 and the standard deviation is 1. So I'll give it the X values, but I'm going to specify the mean is going to be 5 and standard deviation equals 2. And I typed that in wrong because I had another Y from before, remember that? Okay, and this ended up using, okay. Let me just call, alright, there we go. Now I'm going to plot this. Okay, now you see the plot changed. I didn't close this plot window down, it just wrote over it. That's what R will do. There's ways in which you can make different plot windows show up by using dev.new and specifying 3 or 4, an array of graphs that you want to put on one page. For this class, we're not going to do that. Um, just We're just going to use R for the statistics of 253. Okay, so here's a graph, and you can see in this case, you can see what the norm looks like. It's 5, and with standard deviation of 2. So the previous one had a norm of 0, and this one has one of 5 because I specified it. If you want to put another graph on the same page, I can do that. I'll use dnorm again. The mean, let's say the mean is 5, but let's say the standard deviation now is 3. Okay, I'm going to plot this. I've got the values, now I'm going to plot this new. Whoops, I have to use lines because I want it on the same graph. So here we go. And what happened to my plot? Sometimes that plot window gets hidden under the console window. You have to go look for it. So by using lines, I put the second graph, the second curve, on the same graph with the first one. Now I'm going to show how to use the other parameter, pnorm, to find probabilities. In this situation, we're going to look for well, we could say the value of x. Just a second, I can note on the screen here. What we're talking about is having some kind of a normal distribution. And let's say this mean here is at 2. And I'll say that I have some value here of 1.5, and I want to find the probability for an x value less than 1.5. So this would be, what I'm looking for is a probability of x less than 1.5 on this particular graph. Now, in order to use tables in the back of a statistics book, you need to take this x value, change it into a z-score, change this value, well, it's going to become a z-score, change the 1.5 into a z, and then you find the probability of z less than, and I'll just say z tilde, because I'm not going to do it right now, and then you find that. You also have to notice that some statistics tables are giving you the value for less than, some are giving you the value for greater than, some, the ones in the back of Mendenhall give things with respect to the mean. Okay, it's easier in this case because using R, because you don't have to go to the z values, although you can if you want. Those are the default values. You can do it, or you can just issue the command pnorm, give it the value that your value here at the edge. So give it the 1.5, and you want to find the values of x, the probability that x would lie less than 1.5. Specify the mean. The mean in this case is 2, whatever the standard deviation was. I think it was 3. And now, this will give you the less than case. If you want the greater than case, you do the same thing, whatever the mean is, whatever the standard deviation is, and then you say lower tail, lower dot tail, there's a dot in the middle of it, equals, and in capital letters put false. So this is giving you the lower tail. This would give you the upper tail. Find a different color here. So when you put lower tail equals false, you're getting that. So you're getting the greater than. Greater than. Okay, what if you want it between two numbers? I'll recall how to do that from, let me clear the screen. Okay. So you're looking with the probability that some value lies, let's say, between the 1.5 and 3.75. Okay. So the way to do that is you find the probability for everything south of 3.75, and then you subtract off everything that's lower than 1.5. The way to do that in R, p-norm of the 3.75, specifying the mean, specifying the standard deviation, and then subtract the 1.5 mean again and standard deviation again. If you don't put the mean and standard deviation, it's going to assume that's 0 and 1, and you might not get the right answer. So here are these commands typed into R. You want the probability for normal distribution that, say, your x value is less than 47 for a case where the mean is 50 and the standard deviation is 6. Okay, you're going to get, this is the less than case. If you ever want to put a comment on a line in R, just put a sharp sign, and this would be the less than case. Now if you want the same thing, but you want it greater than, then you have to specify this lower dot tail equals false, and that will give you the region above that. And let's see, that looks okay. Notice those better add up to 1, and it looks like they do, because the area that's less than, the area that's greater than would be the entire area under the normal distribution, and that has to have the area of 1. Okay, now if we want it between two values, say 60, and it could be any mean of 2, well, that wouldn't be very good, 55, standard deviation of 4, and subtract off the, this will give me between 60 and 40, and again I have to specify the mean. It doesn't hold that, and that's the probability that the value lies between 40 and 60 on a normal distribution with a mean of 55 and a standard deviation of 4. I'll do a similar demonstration to get the graphs for the t-distribution, and remember again the convention. T is the base name of the distribution, D gives you the points along the curve, P gives you probability, which would be the area under the curve, Q returns the t-value for a given area. So let's just do some graphs. The difference between the t-distribution and the normal is, first it assumes that the mean is 0 and the standard deviation is 1. Okay, so you have to translate into t-values. The second is that it requires degrees of freedom, and that's a parameter that it needs, and you have to specify that. So I'll just give you an example here. Let's set up some x values. Okay, we'll go from minus 4 to 4 again, and plot 100 points. Fine. Now, the y value, I'm going to use D because I want the points along the curve of the t-distribution, and it's going to be against those z values, those, well, x, I guess used x. And now I have to go degrees of freedom equals, and put the degrees of freedom for your case, let's say 4. I'm not going to bother with any, no, that's fine. Okay, now if I want to plot it, again it's plot x versus y. Let's do type equals a line. And you should annotate these with X label, Y label, and main heading, but for this case I'll just go like that, and whoa. Oh, because I typed wrong. Well, and I got the points. There you go. That's the default. And you see here's your t-distribution. Looks pretty much like a normal distribution, except it's very tail heavy. but as the degrees of freedom approach infinity, the t-distribution approaches the normal distribution.